Lesson talks about quadratics. It is a common core. Another word for quadratics for us, to make it easier, are parabolas, okay? Parabolas, okay? And those are our smiley faces and our frowny faces. So there's really two ways to describe parabolas. One is what we call vertex form, okay? And the vertex form has some advantages. The biggest advantage of vertex form is you go straight to the vertex, okay? So this one is in vertex form. There's a little formula for vertex form, and we know that the vertex is just the opposite of this number and then this number. That is the vertex. So in this case, if we take a look at example 1, it's in vertex form. The vertex is right at that, positive 3, opposite positive 3, negative 4, okay? So then we're just going to go to positive 3, negative 4, 1, 2, 3, 4, okay? Now, because a parabola has this shape right here, it's symmetrical. In fact, it's symmetrical along its vertex, isn't it? So it has a line of symmetry, so if you're folded over one side or the other, it folds onto itself, right? That's what a line of symmetry would do. It cuts it down the middle into two equal halves, right? It's symmetrical. So this parabola would have to have a line of symmetry also. And the line of symmetry always goes through the vertex, always. So the line of symmetry would have to go right through the vertex. Can you guys see that in yellow? Can you see that?
Yes.
Okay. I can use my other one. My other one might work out better. There we go. Now this line of symmetry is not part of the graph at all. It's an imaginary line. This little dashed line is just an imaginary line. You'll never see it on your calculator. But for us, it's a nice little line that we can reflect over, okay? So the line of symmetry is a line. Because it's a line, it should have an equation also, right, Lane? So it is a line. Its equation has to be an x-equal equation. In this case, it's going to simply be x equals 3. So the line of symmetry is going to be whatever the x value of your vertex has to be, because it's got to go right through your vertex, right? So x equals 3. X-intercepts. Well, the x-intercepts are where it crosses the x-axis. So x-intercepts is where it crosses the x-axis, okay? It's also, and I want to make sure we put this note because sometimes it's not easy to find it, it is also, it should be a review of things we've done, right? It should also be when y is equal to 0, okay? So if I want to find the x-intercepts, there's a couple of ways I could do it. One, I could just try graphing it and see if I can get nice answers, okay? Boys, we're going to do a seating chart real soon, okay? So just let me finish my lesson and then I'll move us around, all right? So bit by bit. So first of all, we did this before. We go 1, 1, we'll go 1, 2, right? Twice as tall. Line of symmetry, it's over here. 2, 1, 2, 3, 4, but twice as tall. 4, 5, 6, 7, 8. So we'd have another value here. And of course the other one's so tall that I can't get to it, okay? Now let's go back to the x-intercepts. We could guess. We could say, well, it's about 1.5 and maybe 1, 2, 3, 4, maybe 4.5 we could guess. But if we need an exact answer, then we're going to have to do some math. That's all right, I can handle the math. So if I need the x-intercepts, that's when y is equal to 0. So I'm going to go back to my equation and set y equal to 0. So I want to find the x-intercepts when y is equal to 0. So I'm going to go, okay, 0 is equal to 2 times x minus 3 squared minus 4, okay? And solve for x, all right? Well, if I'm going to solve for x, I need to do a couple little things. First of all, let's bring over the 4 first. Before we do anything, let's bring the 4 over, okay? So bring over the 4. If I add the 4, I'd have 4 equals 2 times x minus 3 squared. Okay. Divide by 2, I'd have 2 equals x minus 3 squared. All right, so I'm just solving for x. I added the 4 first. Then I divide it by 2. Now I need to undo the square. So to undo the square root. Think about an x squared, though, is we have to have two answers. So we're going to have a plus or minus. We're going to take the square root of 2, but we're going to have a plus or minus square root of 2. Okay? And then if I add the 3, I have 3 plus or minus the square root of 2 equals x, right? So what does that mean as far as our graph? Well, let me get a calculator and show you, okay? So one answer for my x-intercepts are going to be, one answer is going to simply be a 3 plus the square root of 2, okay? The other answer is going to be a 3 minus the square root of 2, and those are going to be those two values right there. Okay, those are going to be those two values right there. Okay, so that is exactly 3 plus the square root of 2, and that is really exactly 3 minus the square root of 2. Now, if we wanted a decimal answer, we could just use our calculator. And I could go, okay, what is 3 plus the square root of 2? About 4.41. Okay, and what is 3 subtract the square root of 2? And I get an answer about 1.58. Okay, so if we need an exact answer, these are my two exact answers for x-intercepts. Those are my x-intercepts. Exact answers. Now what about the y-intercept? Well, at first I think the y-intercept is 4, right? Because that's normally the way it works. But not in this case. In fact, the y-intercept has to be where x is 0, okay? Now this one's pretty easy to find. So my y-intercept, write this down please. My y-intercept is when x equals 0. So I can figure that one out pretty easily. I'm just going to go here and I'm going to let x equal 0. So if I take my x equals 0, plug it in here, I'll have y equals 2 times 0 minus 3 squared minus 4. So I'm just going to let x equal 0. If I want a y-intercept, let x equal 0. X-intercept, let y equal 0. Say it again. Y-intercept, x equals 0. X-intercept, y equals 0. It's just the opposite, okay? So if I solve this, I'd get y equals a 2 times a negative 3 squared minus 4. I just did 0 minus 3, right? Negative 3 squared is a positive 9, right? So I get y equals a 2 times a 9 minus 4, positive 9. 2 times 9 is 18. I get 18 minus 4, which happens to be a negative 14, okay? So that's my y-intercept. Y-intercept. Positive 18. Sorry, Marie, I'm glad you're here once again.
And
it's 14. Gosh almighty. 14. Thanks, Zane. Thanks, Zane. I blame it on Zane. How's that? Zane distracted me. Got this right here if you want it. Okay. Okay, so not too bad. So again, one more time. X-intercept, let y equal 0. Y-intercept, let x equal 0. Okay? Now, next one. Okay, same thing. It is in vertex form, so our vertex is at negative 2, negative 1. Good, totally right, Alondra. Negative 2, negative 1. I know it's upside down, right? It's upside down. So I'm going to go 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I have a line of symmetry that goes right down the middle so that I can put the other points on the other side. It is upside down because of the negative, right? So I started at negative 2. Oh, I'm in the wrong spot again. Oh my goodness. Don't you hate it when I make mistakes? You guys are right and I'm wrong. Yeah. Oh my goodness. I'll stop making mistakes, okay? So here we go. There and 2, 1, 2, 3, 4, 5. 1, 2, 3, 4 right there. There and there and yeah, I'm gonna go 1, 1, 2, 1, 2, 3, 4. Okay. Goes through right there. Okay. All right, now I like this one. So if I can get my answers by graphing, it makes it really easy. It makes it super easy, okay? So the line of symmetry has to be x equals -2. Yes, x equals -2. Totally right. That's my line of symmetry. My x-intercepts, none. None. Yeah, it never crosses that, does it? Never crosses. So none. Y-intercept I can get by graphing. It's at 1, 2, 3, 4, 5. So my y-intercept is at 0, -5. Okay. 1, 2, 3, 4, 5 right there. That was kind of nice. I didn't have to do all the math. So if I can get it off the graph, I've got it made. Okay. Everybody good? Okay. Turn the page. Okay. Okay. All right. Now. I don't know if, so let's do this. I don't know if we need to do all of these because these are pretty similar to what we just did. Let's take a look at 3 real quick, okay? Huh? Let's do, yeah, let's go straight to 3. Let's just do 3, okay? Because I think the others are pretty similar. Okay, vertex. Where's the vertex? Zero, -3, right? If I graph it, 1, 1, 2, 1, 2, 3, 4, right? I will hold up and wait for you, okay? Okay, I'll wait for you.
Can you also find the intercepts on the calculator?
Nice. Yes, you can. But if we want exact, we're going to have to do it a different way, okay? This one's actually pretty easy to get the intercepts. No, they'll never get the exact. Yeah. I'll show you. In fact, let's do it. It's worth doing it. It's a really good question, okay? Let me show both this time, okay? All right. So, this intercept's easy. You guys agree the y-intercept's easy? Y-intercept's just going to be at 0, -3, right? Line of symmetry, that's easy. Yeah, it's just x equals 0, right? Right, straight up and down, x equals 0. But now the x-intercepts. So they're about here, right? About 1 point something and -1 point something. So let me show you what Lane said, because Lane had a really good idea. So if we wanted to get them off the calculator, it will work, okay? So let me go y equals, clear this, and if I do my y equals my x squared, subtract 3, get my decent window here. Oh, that'll work. That'll work. Graph. So you can see them. So there is, second, calculate zeros. Do you see it? So you can do zeros. We've done this before. Left bound, which is actually above it. Does that make sense? If it's left of it, it really is above it in this case. Right bound, right is really below it because it would be left and right of it, even though it's above and below. Guess. So I get, well, -1.732, blah, 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 right? So I get a -1.732. Okay, Lane, great. However, that is actually the square root of 3. Negative square root of 3, okay? So how did I get, where did I come up with negative square root of 3? What if we took this and we solved it? What if we let y equal 0 and we solved it? So what, let's add 3, okay? And then let's take the square root of that and guess what we get?
1.7.
Well, exactly. How about the square root of 3? How about plus or minus the square root of 3? So if I need the exact value, plus or minus the square root of 3. If I just need an estimate, 1.7 will work, okay? All right? So it all depends on the question. So if the question says, I need an exact value, okay? If I need an exact value, you have to give me this. If the question doesn't say exact value, then the 1.7 is going to work, okay? Yeah, Elijah, does that make sense?
Yeah, it makes sense. I'm just wondering why there's a plus in this.
Oh, such a good question, okay? Real quick question, okay? Let's just do something like this. Let's go x squared equals, let's go 16, okay? So what number squared is 16? Yeah, what about negative 4? Right, now, if you know, now it is both answers. You agree with both answers? What if we did this a different way and brought over the 16 and we factored? What would you get? X plus 4 and x minus 4, which really shows two answers, doesn't it? Yeah, great question. Okay, let me go ahead and push stop.